moving on to the next topic, we have directional derivative. So directional derivative is with respect to the direction of a particular vector. So for the scalar function phi x comma y comma z, we consider our vector a bar and we take a derivative in that direction. This is given by gradient of phi dot of a bar by magnitude a bar. The greatest value of a directional derivative of a scalar phi is gradient of phi. This is just a point we can remember. Find directional derivative of x square plus y square plus z square at point P 1, 2, 3 in direction of line PQ, where Q is phi, 0, 4. So phi equals x square plus y square plus z square. Gradient of phi is the partial derivative with respect to x, y and z, which is what we get over here. Since this is at point P, we can substitute the values of 1, 2, 3 in place of x, y and z. Now our P bar from this point, 1 becomes I cap, 2 becomes 2j cap, 3 becomes 3k cap, taking in vector representation. Similarly, Q will become 5i cap plus 0j cap plus 4k cap. So now the vector which we require A bar is given PQ bar, which can be written as Q bar minus P bar. That's how we get 4i cap minus 2j cap plus k cap. Just subtract the two. Directional derivative of phi in direction of A bar is given by this formula. We know the value of delta phi from up here. We know the value of A bar from here, and we can take magnitude of A bar as root of x square plus y square plus z square. That's your solution. The answer is 6 by root 21. Find constant a comma b such that surfaces ax square minus byz equals a plus 2 the whole into x and 4ax square y plus z cube equals 4 intersects orthogonally at 1, minus 1, 2. I forgot to write the word intersects. Phi 1 is equal to this, you take everything on the LHS. Phi 2 equals this, again take everything on LHS. So you can say del of phi 1 or gradient of phi 1 is equal to this partial derivative with respect to x, y and z. Del of phi 1 at 1, minus 1, 2, which is the point given in the question. We substitute x, y and z as 1, minus 1 and 2. Similarly, gradient of phi 2 partial derivative, we substitute 1, minus 1, 2 to get this value. Since they are orthogonal, we can say the cos theta equals 0, because orthogonal means it's at 90 degrees, right? So cos 90 becomes 0. We can take the cos theta formula, delta phi 1 into dot product delta phi 2 upon the product of the two magnitude of the gradients. Cos theta becomes 0, so your denominator goes away. You end up with del phi 1 into dot product of del phi 2 equals 0. Del phi 1, del phi 2 you have up here, you have already proved it. You take it at the point 1, minus 1, 2, you take those values and you take a dot product. On taking a dot product, you get this equation. Now 1, minus 1, 2 lies at the intersection of phi 1 and phi 2, hence it will lie on both planes. This is the equation for phi 2 when we take everything on LHS. So we can substitute 1, minus 1, 2 over here. And from here we get a value of A. From A we get A equals 1. Now this we can substitute it back up here, and that's how we get the value of B. Value of B is minus 2. The next part is divergence of a vector. Now a vector function f bar has divergence denoted by div f bar, where div f bar is the dot product of del into f bar. So del we know is this, f bar is your function, and that's how we do it. The divergence of a vector is a scalar value. If divergence of f bar is 0, then f bar is a solenoidal vector. This point you have to remember, because in the paper they'll give you directly a solenoidal vector. A curl of a vector is where you take del cross f bar. So it's the cross product of f bar. You know, we can solve the cross product with the determinant I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. F bar is your value where f bar is equal to f1 I bar plus f2 j bar plus f3 k bar. Curl of a vector is a vector, and del cross f, if del cross f bar is 0, it is an irrotational vector. If r bar is a position vector, find divergence of r bar and curl of r bar. So r bar is any position vector, so we generalize it as xi bar plus yj bar plus zk bar. Divergence of r bar is going to be del dot of this. We take a dot product, so we get dou by dou x of x, dou by dou y of y, dou by dou z of z, comes 1 plus 1 plus 1, which is 3. Curl of r bar is going to be del cross r bar. Over here we take a del cross r bar value. Now we have I bar, dou z by dou y minus dou y by dou z. We solve the determinant like this. Now it's become dou by dou y of z. There's no, it's a partial derivative with respect to y. Since there are no y terms, this becomes 0. This becomes 0 I bar minus 0 j bar plus 0 k bar, which becomes 0.